The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Predictive Analytics using Hadoop. In our panel today, we have two guest speakers. Our very first guest speaker is Mr. Raghavan Swaliam. He is lead business architect at OSSQ. And our second speaker is Mr. Anurag Datta. And he will today introduce all of us about OSSQ. So without any further delay, I introduce you all to our guest speaker. Over to you, Anurag.
Hi, thanks Gaurav, and thanks to everybody for taking time out of your schedule for this webinar. I will take a little time of yours in introducing OSSQ, and then I will pass it on to Raghavan to start the webinar. OSSQ is a leading global open source software focused company providing an integrated value chain of services encompassing outsourced software product development, product customization and implementation, consulting and training services on open source product and technologies. We have principal locations spread across North America, UK and India. When it comes to specific to Hadoop, we have dedicated Hadoop practice. With partnership, we are the Cloudera training partners for last 4 years, and we are their partners. We have been doing trainings in Cloudera for last 4 years. We have trained around 600 plus people in Cloudera developer, administration, data analyst stream. We are also the AWS advanced consulting partner. This is very important because when most of the organizations tend to start with Hadoop, they want to start with the AWS instance. So we have both AWS competency and as well as the Hadoop competency. Over to the next slide. One thing which separates OSSQ from the other organization is that we have got a broad set of competencies, but our greatest strength and basically what separates us from other open source solution providers is the ability to integrate many application and open source product into a solution that can help you to meet organization business objectives and differentiate customers from their competition. We basically have a goal to become a trusted advisor for our clients and help them drive innovation and constantly improve the customer experience while streamlining their business processes and improving productivity. And if you can see in the spread in the presentation, we are the platinum partner for Sugar CRM. We are the partner for talent. In fact, we are the only partner for talent in entire India and Asia Pacific. We are the Cloudera training partner. We are partners with Magento. So, and this gives an example how we come up with the integrated business solutions to understand the organization's requirement and come with a business solution. As far as our big data competency is concerned, we extensively bring big data capabilities to our customer. We are the preferred partners with Cloudera, preferred partners for global cooperation who are looking for solutions in big data management and big data analysis for the data-driven applications. We have a full line of Hadoop consulting and integration and training services which enable you to put your structured and unstructured data in action with respect to your data analysis. And we basically leverage the powerful new data platform which is built on Apache Hadoop open source software package to come with the solution to your problem related to the data. We are, as far as the talent is concerned, which is required for putting data into the Hadoop, we are also their partners in geographies including UK, US, India, and as far as the training is considered, we are the Asia's first Cloudera Hadoop certified training partner. As far as our Hadoop offerings are concerned, we basically have Hadoop consulting services which are focused on evolving the enterprise data management and capabilities that unlock the business value of big data. We provide the hands-on expertise and guidance to help enterprise evolve strategies for successfully acquiring, organizing, and analyzing big data in order to drive real business insights to help the bottom line. If you can see, we have Hadoop consulting offerings where we focus on especially on the big data strategy and the roadmap. As some organizations starting with the big data, we focus on the use case discovery workshop. We also understand the organization readiness, whether the organization is really ready to start with Hadoop practice or not. As far as the Hadoop implementation is concerned, we are into architecture definition and the selection as well as the various frameworks are concerned. We do a rapid proof of concept. We do the sort of the implementation of the entire solution and the other administration services. The basically focus is to that we have a proven track record of designing architecture roadmap for mission critical and large applications for a number of Fortune 100 to set up organizations. We create big data architecture utilizing Hadoop that is extensible, high performing, and integrated with other information systems. And as far as Hadoop support is concerned, we also have support contracts to fully manage service contract, and training is the one thing which we have been doing for last 4 years, and we have trained large number of people in India. In fact, we can proudly say that we have done training in every SIs in India, big SIs in India. Passing on to a small introduction on the Raghavan, who is the speaker today for the webinar. Raghavan has got 17 years of experience in the IT industry, and he is the Cloudera certified trainer for developer, administrator, and data analyst stream. And his experience covers Hive, Bake, Blue, Scoop, administration, HBase. He is also familiar with the NoSQL technologies such as MongoDB, and he is currently pursuing in machine learning and data sciences. Now I would like to pass this on to Raghavan for the webinar.
Hello, Gaurav, can you hear me?
Yes, I can hear you, Raghavan.
Hello?
Yeah, Raghavan, we can hear you. Please go ahead.
Yeah, thanks Anurag and Gaurav. Welcome everyone for this webinar on predictive analytics using Hadoop. So thanks to everyone who has taken time out to attend this webinar. So what an exciting way to start our weekend, right? Learning to know how to predict, trying to find out what our friends are going to do over the weekend, or what our friends are going to do, over a month, what our bosses are going to do. It's all exciting to predict the things, right? So let's start looking at the predictive analytics specifically using the Hadoop. So the expectation from the audience for this webinar is that they should be aware of the Hadoop at its basic format and a little bit of predictive analytics as well, because this is more about doing predictive analytics on Hadoop. So having a knowledge about both these areas is definitely going to help. So in this webinar, we will see what exactly predictive analytics is, though the expectation is you should be knowing a little bit of predictive analytics. But let me start by explaining what predictive analytics is and how it is done. So we'll also discuss about prediction models specific to the statistics and predictive analytics discipline of the analytics. And then we'll also look into some use cases which are which leverage these prediction models, and we'll finally look into how Hadoop can be utilized for implementing these use cases, and what are the ecosystem and the tools that are available in Hadoop to do these things. So we'll also look at some example workflows, what are the tools that can be used. Working in Hadoop is always a little bit confusing because there are so many tools doing similar kind of stuff, so we should understand these tools well and choose these tools. So we look at a couple of example workflows using different tools, how you can implement various prediction algorithms. And the last 10 to 15 minutes, we'll leave it for question and answers. So in case you have any questions specific to this presentation, then we can discuss those questions as well. So first of all, what predictive analytics is, right? So it is a BA technology that predicts the outcome based on the past experience. So you have some experience in dealing with certain things. So let's say that you see that a specific kind of house values some amount. So based on various features. So let's take that example and then go over it. If you take the house pricing based on the square foot, right? That's what we do. We go to various sites or builders and say, I am looking for a flat of this size, 1,000 square foot or 2,000 square foot or something like that, and we get the price based on the square feet rating. Right? So if it is a single builder, it is fine. But if you want to find out, let's say, take a city like Bangalore, and then try to predict the house prices in a specific location. Right? So if you take the simple variables like I've shown in the screen, where you have the data about the square feet of the flats that you're looking for and the price. Right? So given this data, will you be able to predict a new house with a given size of square feet and predict the price? Right? So let's see if we can do that or not. So if you try to plot this data on a graph, right? So we must have seen these kind of graphs from our childhoods, right? So we have a graph here where we can plot our data, square feet versus the price of the house. Right? So if you try to plot this data, so this is how probably you will get. Right, you have a house, 1,000 square foot house priced at $100,000 approximately. Another house of 900 square feet at $92,000. So if you try to plot these dots, so this is how we will get. Immediately we can see there is some pattern here. There is some pattern here. So based on this pattern, will we be able to predict the price of a new house? For example, say that you want to purchase a house of 2,200 square feet, and will you be able to predict what is the right price for it based on this data? Right? So looks like we'll be able to predict. So basically, looks like this is following a linear trend like this. So if you try to plot a line to these data points, so this is the kind of line we will get. And also, we can approximately say that the price is equal to 10 times the square feet size. Right? So it has a linear relationship here, and the formula that the model tells us that the price is 10 times the square feet rate. So given a new house of let's say 2,200 square feet, so the approximate price, a reasonable price, is around 220,000 square feet. Right? So this is how we'll be able to tell what is the price of a new house. But unfortunately, the number of variables that we get in real life are enormous. For example, if you take the case of predicting the price of a house itself, so you will have a lot of variables. Only the square feet is not going to be the variable for you. So you might consider the location. You might consider what kind of fittings, what kind of furnishings that the house has, and then how many bedrooms that house has. Does it has balconies? Right? What is the vicinity to let's say a market, to a highway, or a mall? Right. So all these kind of factors will come into a picture. So in real life, if you take to price a house, it's a very, very complex thing. Right. A lot of factors are going to the pricing pricing a house right. But in the previous example that we have seen that there is a near linear relationship between the variable and the price. Right? Sometimes that may not be the case. So you may have a lot of variables, a lot of parameters to predict the outcome, and then the relationship between these parameters, these variables as well, could be non-linear, so it could be very, very complex. So how can we do the prediction in such cases? So if you really see the relationship between these various variables and the outcome, it could be very complex. Right, as here I have shown a graph, a three-dimensional plot for a three-variable function. Right? So this itself is looking so complex. Just imagine you have a function which depends on 1,000 parameters. So that's what the truth is. So if you want to predict the price of a house, you will have so many variables. If you want to predict the behavior of a customer, there will be so many other parameters, right? The urgency that he's in, and the discount, or the amount of the budget that he has. So a lot of other factors are there, which are some are visible, some are invisible. Right? In such cases, so how do we make a prediction model which can tell what our customer is going to do in the future? Right. So this is basically, it is not the job of a programmer, but we have something called as prediction models. Right. So what prediction models will do is that based on the past data, which is also called as a training set. So the training set defines what was the outcome based on certain parameters or features. They're also called as features. So based on certain features or the parameters, what was the outcome in the past? Right? So you will have a huge collection of the training data like this, and a model will look into this data and learn. It will learn from this data and make models. Right? So using these models, you will be able to predict the outcome of a new input. So given a new input, it will be able to approximately predict what is the right output for it. Right? So, and there are a lot of models to do this. Linear regression is one of them. So the one what we applied for the house pricing is the linear regression. And also there is other algorithms called as classification, clustering, and recommendations. Right? So these are used for various other predictions. Right? In linear regression, we want to predict the outcome given a set of variables. Excuse me. But in classification, we want to classify whether one of the example I can give is the spam filtering, whether a mail is a spam or not. Right? And clustering is when you are trying to segment your customers, let's say, or trying to group news articles. Let's say this is a political kind of article, this is sports related article, and so on and so forth. So you should automatically cluster based on your past experience. So there are a lot of algorithms that are there, so not limited to what I listed on this slide. Right? So we see predictions everywhere today. So we are being predicted on a continuous basis. So we are being predicted by our companies, the government, and the healthcare providers like the health insurance providers, our insurance companies, banks. So universities, so there's a lot of companies, a lot of groups that are trying to predict our behavior, the customer behavior, so that they will be able to sell better. They'll be able to position better compared to the competitors. And not only that, it helps the companies combat the financial risk, whether a customer is a good credit or not, whether a customer is going to fall sick. Right? You can even predict those kind of things based on his hospital visits, based on his the habits. So you'll be able to predict what is the possibility of a specific customer falling sick soon. So based on that, they can appropriately, accept the risk or price the premium. So all these kind of things can be done. Right? So it is happening everywhere. So you may sometimes you may get surprised. How am I getting this specific advertisement? How am I getting this specific promotion coupon? Right? So it's all based on the predictions that are going on based on the data that organizations are gathering. Right. So some of the examples I can give is Amazon.com. Whenever you go there, so based on your past purchases or the groups that you are associated with, so it will give you some recommendations. You may be interested in these books as well. Your friend purchased this book, you may also be interested. Right? You have purchased a razor, you may need a blade. Right? So it will recommend based on the past experience as well as the things that you are doing currently as well. So there is real-time predictions as well as offline match-oriented predictions as well. So this is a typical recommendation algorithm that is applied on Amazon, and there is also a classification algorithm which can say whether a whether an email is a spam or not a spam, right? And then so we also have clustering, right, in governments and in companies. So you segment your customers, segment your population to specifically target, right? Saying that this group is a high-income group, low education, or low education, low-income group. So based on that, you will be able to sell or suggest the right products for them, and be able to sell better to your customers and serve better to your customers. So these are some of the samples of the predictions that are happening in our current world. Right. But the important thing for these predictions is the data. Right. So how are the predictions are being made? You have some experience data in your data base, right? So which says that these kind of parameters have led to this kind of outcome. So you have a huge collection of the samples which are called as the training data. So based on this, you are evolving a model based on the algorithms that were mentioned before, and then using that model, you are trying to predict the new outcome. Right? So it's very important that you have the right set of the training data. Right? So the more, and also you should have sufficient data to train your model, to create your model. If you don't have sufficient data, and your prediction might go wrong. If you, let's say if you just have 2-3 sample data, your prediction may not come very well. So it may fall off the line from the reality. So the more data you have, the better prediction you will be able to do. Right. So so how to collect this data? How to make sure that it is of the right type that we are looking for? We'll look in the next slide. Right. So, but the important thing is you have to have the training data and the enough training data so that your model will be able to predict better. So it is said in several predictive analytics discussions that the more data will be able to give better results or beat the best of the algorithms, even with the simple algorithms. So, so having enough data and the good data is very important in predictive analytics. Right. So, so here is an example of a prediction done with the data and with the various algorithms. So like you can see, as the data volumes increase, the number of the words that we have here increase, their prediction accuracy is more or less becoming the same. So remember that the more complex the algorithm is, so more resources it is going to take, more time it is going to take. So you can use a simple algorithm and then use a lot of data to get the performance benefits as well as the prediction, accurate predictions as well. Right. So now, what role Hadoop has in it? So whatever we have discussed so far is independent of the Hadoop. It's more related to the statistics and the mathematics field. So given a set of the data, how do you create a model out of it? Or in other terms, if I say that given a set of the data, how do you create a formula? Right. So even if you take some of the famous physics equations like F is equal to MA, E is equal to MC square. So these are not, these formulas are made from the data. So these are also prediction models if you frankly speak. So based on the data that scientists have collected, they have formulated these. Right. So those are basically the models which are independent of the Hadoop. So what role Hadoop has in this predictive analytics world, right? So on the previous slide, we have discussed that having enough data and the reliable data is very important. Right? If you have less data, your prediction is not going to be correct. Right, so you have to have enough for the sample data. It's also important to have enough data because we discussed on previous slides that you will have enormous parameters. So there are some of the functions where you can even find 10,000 parameters. Right? So if you have to predict with so many parameters with certain accuracy, so you need to have a lot of the data which indicate the behavior of a particular function or environment based on various variations of these parameters. So it's very important to have a lot of data, huge data for doing the predictive analysis. So when we are talking about the lot of data, so we should have the ability to store it. We should have the ability to process this data, which is very important. So which Hadoop can provide, right? So if you look at Hadoop, Hadoop is a popular big data platform, and it can store petabytes of data at a very cheaper price, at a very low, per gigabyte price. And it's reliable. It's not only cheaper, but it is reliable as well with its fault tolerance mechanisms that are inbuilt. And also it has the ability to process the data in a distributed parallel way, so which makes large amounts of data to be processed at a very cheaper price and as well as efficiently. Right. So if you look at, I assume that you are already familiar with the Hadoop fundamentally and what kind of features and tools that Hadoop ecosystem has. So just for the benefit, I just repeat here. So Hadoop basically has a storage system, which is the HDFS. It is a distributed storage, so which means that you put some data into the HDFS, so it will be distributed and stored on the cluster of the computers. Right. And it also has the latest version of the Hadoop also has a resource management layer called as Yarn. And on top of which you have various frameworks like you have the MapReduce, using which you'll be able to run develop and run programs in MapReduce, which is more batch oriented, and also we have the Spark framework, which can run on Yarn, apart from other frameworks that it supports. So using Spark, not only you can do the batch oriented processing, but also you can do stream oriented processing, real-time processing, in-memory processing as well you can do. And so like that you have a lot of tools and ecosystem in Hadoop which can work together to process the huge data that we talked about. So the top stack, I did not give any names because there are a lot of things which are higher level abstractions like Big Hive, and then Spark independent libraries. So some of these things are interoperable as well. For example, if you take Big and Hive, they can work on, for example, Hive can work with the HBase as well. So I really did not wanted to name those layers. So this is what Hadoop can do, and the ecosystem that we have. So speaking specifically about the predictive analytics, what kind of support the Hadoop provides? So if you look at the Hadoop, we have enormous set of the support and the tools for predictive analytics. We have Mahout, which was probably the first machine learning framework on the Hadoop, which is a Java library of this machine learning algorithms like regression and then clustering, classification. All these things are implemented. You basically have to pass the data and call the respective library, and you will be you will get back the model to you for your prediction. So we also have the Solar. Solar is not really a machine learning or the predictive analytics tool, but you can use this in combination with other tools like Mahout or other tools so that you can index and do real-time analytics, but it's not really a machine learning tool. And the latest addition to the Hadoop, which is the Spark. Spark has also enormous support for the machine learning. It has a separate framework called as ML Lib, using which you will be able to run machine learning algorithms on it. And also R also is a very beautiful tool, one of the favorite tool for data analysts as well as data scientists today, which has enormous support for this modeling. So we also have integration with the Hadoop through various means. You can run R programs through Hadoop streaming. There is a framework called as a Big R, using which you will be able to write MapReduce programs. And then Spark has a separate framework for supporting R, which is Spark R. And also there are other commercial tools as well. For example, Scala R is supported by a tool called as Revolution R, which is also getting popular. And there are a few other commercial tools like Skytree, which is commercial and non-open source. It's not an open source tool, but it implements most of the predictive analytics analytic algorithms in it. So this is a kind of support what we have for predictive analytics in the Hadoop ecosystem. So now if you look at the common Hadoop analytics flow in Hadoop, what exactly happens. So this is how it looks like. Right? So you have various data sources on left. It could be streams, or it could be some your operational databases, or it could be your REST services from which you can pull the data, right? And then you can pull this data using various tools like Flume, which supports the streaming the data sources, and then Scoop, which supports your operational databases running on RDBMS. Right, and then NFS can have your other data files, probably the internally generated data files can be there on NFS. Right? So we use various tools, and then we ingest the data into the Hadoop platform, which will sit in HDFS, and then using various means you can analyze this data. You can use SQL engines. Which interface with tools like Hive using ODBC or JDBC kind of connectivities, and then generate the reports. And also, you'll be able to do real-time analytics as well using this data using the tools like Spark and Solar as well. Right. So this is how a typical workflow looks like in the Hadoop analytics world. Right. Sometimes your data will also be ingested or exported into your enterprise data warehouses as well, so that your business intelligence tools, your high-value reports, will be able to run directly from your data warehouses and nodes. Right. So, one of the point what we discussed is that you need to have enough data and the right data in the sense that if you are filtering mails as spam or not spam, you should have the right training the data. Given a mail, you should be able to say you have to tag it saying that yes, this is a spam, this is not a spam. Right? So this is what is the training set. You have to have enough examples like this for your model to learn from this collection of emails, and it will be able to predict a future email whether it is a spam or not. Right? So how are you going to tag millions of mails as spam or not spam? So one of the technique that is used in industry is use crowdsourcing. Right? You can get your work done through various crowdsourcing forums like Amazon, Turk. So there are a lot of other forums from there you can get your work done, especially the tagging of your resources, tagging of your training data at a very cheaper price. So you can use crowdsourcing. And then use obvious features. So we discussed about the features. Features are the ones which predict based on their values. They predict the value, or they decide the outcome of that specific thing. So, for example, if you consider a house, the features of the house could be the size of the house, and then the location of the house. Like that, there could be several features. So when you're taking a business scenario or a specific use case, so you have to decide what features are the right features, what features are not correct. So one of the suggestions is use obvious features so that your model will not get too complicated, and you will also understand the behavior easily. And also another important thing is that use the feedback from the user behavior. Sometimes your model or the data that you have will have some short falls. So it may not have certain behaviors of the user. So always take the feedback to the user behavior, and that will give you more data for your training data set. Okay, this particular scenario, there is a deviation from the prediction, so you can use that, add that to the training data set. So thereby your future predictions, future models will become better and learn from this specific feedback that user is providing. So these are some of the techniques and thumb rules for getting and using the big training data. So at the end, I would like to show you a couple of examples or the sample workflows using the Hadoop ecosystem, how you can implement the predictive models in Hadoop. Here we have a recommendation system using Mahout and Solar. Like I said, the Solar is an indexing tool in the Hadoop ecosystem. So thereby, the searching will become searching on the big data will become easier, right? So here we can use Mahout for the heavy number crunching. So thereby, we have all the historical data that we have, either it could be log files or anything. So they can be crunched, and then the co-occurrence. So for recommendation, you have to have the co-occurrence. What are the things that users do together, or buy together, or purchase together, right? So this is called as co-occurrence. So the co-occurrence can be calculated. Typically, it is done using the recommendation algorithm. So this can be executed on Mahout on the data set that we have on the HDFS. And then this can be fed into the Solar for indexing. So basically, the indexing will contain things like things that co-occur together. For example, a person who is buying a pen is going to buy some ink also together. So it is very, very simple example what I am telling, but there could be very, very complex things, so which can be pre-computed and then be pushed into your Solar indexing. So thereby in future, if we want to access, we'll be able to access it. Right. So we use Mahout for the heavy number crunching here, and then Solar for indexing. So once we do that, when the user comes in for purchasing something or browsing your website, so you will be able to based on the user action at that point, like what is purchasing or what is browsing. Based on that, you will be able to search in your Solar system using the Solar index, and then get the relevant recommendations for him, and then display that along with display it on the user's page, so that you will also recommend the related things together. Right. So this is how we can use Mahout and Solar for doing the recommendations. So you can also use the Spark independently for, so let's say, logistic regression, which is used for classification typically, and also it can be used for many other things. Right. So once again, we have the data in HDFS. So you can use Scala or Python. You can use Python as well on Spark. It supports both these languages. So you can use Scala or Python for pre-processing your data and feature generation. So remember that the feature generation is an important thing in predictive analytics workflow, because when you get the data from your, let's say, weblogs or from your blogs or from any other source, you don't know what features it has. Right, so you have to generate the features as part of your processing at one stage. So you can use Scala for that. You can do pre-processing, cleaning up of the data, and then feature generations. Once you have the feature generation, then you can use the ML lib of the Spark for doing logistic regression or other algorithms like SVM. You can use, and then this can be pushed either onto a data model or into the Hadoop itself, HDFS itself. You can store, which can be later either accessed by the VA tools or web applications for using this data for report generation or recommendations as well. Of course, the classification, logistic regression is not suitable for recommendations, but you'll be able to see the groups, right? Based on the groups, okay, this specific group has this kind of characteristics. So what is the right thing for this specific group? So that way you will be able to, suggest the right things for your that specific user group. So this basically brings us to the brief, introduction to the predictive analytics using the Hadoop. But not limited to what we discussed here. There are several other tools that we have. Like you can use Storm for doing real-time predictive analytics, along with the other libraries that we have. Or you can use R extensively for doing predictive analytics. So there are a lot of other tools that for you to go and explore and find the suitable tools for your specific use case. So thanks for listening. So I will open it up for question and answers now.
Thanks, Raghavan, for such an insightful presentation. Let us quickly take up question now. I request you to please read out question first before answering them, so all our users may listen to the commendable insights.
So hello. Yeah, hope you can hear me. So there's a question, which is the best tool used for predictive analytics in Hadoop. So it's a very tough question to answer today. because there are a lot of tools like we just discussed. You have the tools like Mahout, you have specific libraries on the Spark, you have one of the favorite tool like R, which is a very good tool from a statistics perspective. So it's very difficult to say. You have to choose based on the use case that you have. For example, you have the real-time use case. Then you have to go with a combination of either Storm or Solar kind of the thing, along with your analytical tool like or Spark MLib kind of the thing. Also, sometimes you have to make a decision based on the skill set that is available within your organization. Suppose you have more of, let's say, Python programmers, then you might prefer Spark, or you have, let's say, experienced R programmers, then you might prefer R in combination with other tools that, other tools that Hadoop offers. So there is another question here. Do we need to buy Hadoop, or we need to programming for developing the Hadoop? So the question is not very clear, but however, I understand that whether we need to program completely or we need to purchase a ready-made solution. So if my understanding is correct, you need to program a lot. Right, you have to set up Hadoop. You get the Hadoop as a, in its basic format, which we need to set it up and then configure all these tools and integrate, and then you have to go and program based on the tools that you have chosen. Okay, so there is another interesting question. The Hadoop is a software or the hardware, right? So it is a software. It's a software which can do distributed parallel processing, and it can run on any kind of the hardware. Of course, most of the times it is referred to as the commodity hardware. Right? It is not a hardware. Okay, so there's a question here that Hadoop can be used to import data into data warehouse. So does Hadoop provide any tools? Yes, Hadoop provides the tools like we discussed on one of the slide, how you can bring data into the Hadoop. Or take data out of the Hadoop as well. So there's a tool called as Scoop, which actually is the short form for SQL to Hadoop. So this tool, using this tool, you can bring in data from an RDBMS into Hadoop, as well as from the HDFS HDFS storage into a data warehouse as well, assuming that it is a RDBMS data store. Yeah, so there's a question here, can we use SAS or with Hadoop? Exactly, so that is what I discussed towards the end of this the presentation. SAS has its own connector, so I do not have the complete idea about how SAS works with Hadoop, but R has several ways of working with the Hadoop. Or can work with the Hadoop in using Hadoop streaming, where it runs as a distributed process but independent processes by interfacing the Hadoop through standard input and standard output. So that is one way. The other way is it has another MapReduce compatible library called as Big R, using which we will be able to run distributed programs using the R language itself. And then there are other ways of integrating R with the Hadoop using Spark R, and then there are a lot of other connectors provided by some of the commercial tools like Oracle, Netezza as well. So yes, R is very well supported on the Hadoop platform, but you need to do a little bit of work on the integration. So there's another question: how is indexing and the co-occurrence interconnected? It is not really interconnected. It is yes and no. So the co-occurrence, the algorithm, what it is doing. So you bought, let's say, an apple, right? You bought an apple. Based on the data, the training data that I have, what are the other things that are suitable recommendations for that user? So a person who purchased an apple may also buy an orange, right? Or you can also say that a person who purchased, let's say, a pant may also purchase something else like, say, a bat, which are totally unrelated, but that is the kind of insights that you would get. So, but this you don't run every time, right? Whenever the user comes in, you don't run this co-occurrence algorithm every time. So you do this, and then at that point of time, based on the training data set that you have, at that point of time, you can say that a person purchased a certain thing may also be interested in other things like B, C, D, E, F, something like that. So this is the indexing data that I talked about. So a person purchased A, he may be interested in B, C, D. A person who purchased, let's say, X, he may be interested in M, N, O, P, something like that, right? So when I have this data, I don't need to go and do the co-occurrence algorithm again and again. So when the user comes in real time, I can just query this index and then present the appropriate recommendations at that point immediately based on the indexing that was done in the past. So we have a few more queries. So can you suggest a reference book for the big data? If you are a beginner, my recommendation is always to read Hadoop, the definitive guide. But if you are an analyst who is comfortable with, say, who is comfortable with the SQL kind of things, then I would recommend the other books, maybe Programming with Peak, and there is another book called as Programming Hive as well. But if you are comfortable with the Java and you want to understand the architecture, Hadoop, the definitive guide is the best book. So here there's another interesting question. Can we implement the Hadoop on Windows platform using C#? Yes, definitely you can do that. On Windows, it is not supported by Apache, but Hortonworks has a specific release for the Windows Hadoop on Windows, and you can program using C# there. It is supported. In fact, C# is supported on normal Apache Hadoop as well, using an interface API called as Hadoop pipes. Using Hadoop pipes, yes, you will be able to program in any format of Hadoop. Can predictive analysis be used for the human emotions? In fact, yes. So how exactly, I don't have enough information, but I was going through an article a couple of days back, which says whether it can say, based on what you are typing, the kind of words that you are writing. Right, it's not a single sentence, but if you take the recent sample, maybe a paragraph or something like that, and you have, let's say, some of your previous written samples, you'll be able to do modeling and say that what kind of emotion that user has at the point of the time. So yeah, it has gone much beyond that nowadays, beyond the human emotions. Predictive models. So there's another interesting question. Can I use traditional BI tools with Hadoop, like ClickView, Spotfire, Tableau? Yes, you can use. It's very easy nowadays for BI tools to integrate with the integrate with the Hadoop because the tools such as the Hive provides the JDBC ODBC connectivity. So thereby, they just need to, the tools will treat the Hive or the Hadoop data source like any other ODBC or JDBC source. They really do not differentiate. So you just need to have the right driver, and then you'll be able to access, query the data using these tools as well. So I'll take one more question, and then I will call it a day. Okay, so other than MapReduce, any other options to crunch the data in Java? So in Java, no, at this point of the time, other than MapReduce, you don't have. So if you want to stick to Java to crunch your data, yes, you have to depend on MapReduce at this point of time. Alternately, you have other frameworks. If you go to let's say Spark, if you are using the Spark can support other languages such as Python, and then Scala is supported. Even Java is supported there with Scala. Okay, so I think you know the question that if you want to process the data using Java, yes, you can do that using Spark as well. Spark also supports Java. So, so other questions I will take a look offline, and then I'll try to provide the answers maybe in a couple of days. So thanks once again for your time. So hope this was useful for you, and then you'll be able to. I wish all the best for your further learning in predictive analytics.
Thanks.
Are you there?
Yeah. Thanks, Raghavan. I'm really thankful to our guest speaker for conducting this webinar and taking so many questions. It was really a great session. I would also like to thank all our participants for making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all.